Hello. In this presentation, we will be discussing the ways web-based services and the Internet of Things, or IoT, are used to support farm irrigation. To begin our discussion, we'll provide an overview of the IoT, including an explanation of its basic components using the Cisco model. Next, we'll explain the need for automation in irrigation systems in farms, then provide an explanation of smart farming and explain the role of precision farming in promoting IoT. We'll explore other current web and software trends taking place in agriculture and irrigation, and discuss examples of established software solutions that exist to promote the use of IoT in commercial farms. Then we'll show examples of how small and rural farms alternatively implement the concepts of IoT. We'll wrap up our discussion with some of the challenges present in IoT and its application in this industry. We'll finalize by presenting our concluding remarks on our research. The Internet of Things, also known as IoT, is a system of connected objects such as gadgets, automation modules, sensors, and devices that all can collect and exchange data. There are several formal models of IoT, one of which is presented by Cisco. This model has identified 7 different layers. The first layer is physical devices and controllers, otherwise known as the things of IoT. The second layer is connectivity, the layer that connects devices in a network. The third layer is edge computing, the cloud and remote services that are used to implement an IoT platform. The fourth layer is data accumulation, the storage of the data that has been measured and gathered. The fifth layer is data abstraction, the processing, summarization, and access of the data that's been gathered. The sixth layer is application. At this level, business intelligence and analytics are performed. The seventh and final layer is collaboration and processes, referring to the people and business processes that will utilize the analytics performed. The IoT, though made possible with technology, is a model made of gadgets, analytics, and people, all coming together to gather and use data in new ways. The IoT has the potential for application in any industry. Before we explain the involvement of IoT in farming, we'll explain the challenges most countries face in their irrigation systems. Irrigation can, first of all, be human resource intensive, in some places requiring entire labor forces just to water crops. Due to lack of mechanical techniques, many farms employ inefficient irrigation methods, like flood irrigation. By not being able to track which parts of a farm need to be irrigated and at what amount, farmers will flood their entire farms with water, creating excess runoff and unequally watering their farms where the landscape isn't level. And since farms use fresh water, agriculture ends up using 70% of our world's fresh water resources annually. And the conventional solutions that are offered can be costly, requiring large investments in new equipment or technology. The solution is to create affordable, automated systems that can keep track of crop-related data and automatically irrigate using available resources. Smart farming doesn't have to involve the highest level tech, but rather intelligent use of technology at different levels. Throughout human history, there's been a constant need to increase our food output. Dating as back as early as 6000 BC, farmers found that they could plant crops in arid climates by redirecting water from rivers and streams. The first forms of irrigation were implemented, allowing us to feed our growing population. Then, hundreds of years ago, farmers found that when they planted the seeds from crops that gave them the best yield, the plant's traits would be passed down, a term called selective breeding that again improved our food output. Just over 50 years ago, scientists then discovered a way to genetically modify food in the lab to prevent crop disease, make food last longer, and dramatically increase yield to feed millions of more people. The Green Revolution was marked in history as the introduction of GMOs into our common food supply. With our world population continuing to grow and global food demands expected to increase by as much as 50% over the next 40 years, the need to improve food production continues. Modern scientists believe that our next step in increased production will be best achieved through smart farming. Sometimes the terms smart farming and precision farming are used interchangeably. We'll discuss precision farming next, but the term smart farming simply refers to the utilization of any modern technology to increase agricultural output. These modern technologies include things like cloud computing, geographic information systems, and of course, the Internet of Things. By using new technology, smart farming enables farmers to collect data and improve processes, allowing them to improve then their farm's total output. Precision farming, also known as precision agriculture or precision ag, is focused on the use of new technologies to increase crop efficiency and yield, profitability, and sustainability, while simultaneously lowering the levels of traditional inputs needed to grow said crops. These traditional inputs include things like land, water, herbicides, insecticides, and of course, water. And the new technologies that precision farming aims to employ include things like GPS systems, control systems, sensors, robotics, drones, autonomous vehicles, automated hardware, telematics, software, and of course, the IoT. By using new technology, farmers can collect new data about their crops and then use that data to make better and more informed decisions. The data collected is achieved through remote sensing technology. Remote sensors can collect a huge amount of data regarding crop health, including water level and hydration. These sensors are contained within wireless nodes that communicate with the controller, which then transmits the information into the cloud or another portable device that has been set up to receive the collected data. These devices are all contained within a wireless sensor network that does the work of recording and transmitting data of crops that cover acres of farmland. With IoT and remote sensing technology, farmers can collect data such as farm temperatures, wind speed, humidity, saturation, allowing them to create precise farm plans and maps for their production. They previously mentioned traditional inputs like fertilizer, herbicides, insecticides, and water can be more precisely optimized and applied to reduce waste, improve yields and profit, and simply be more environmentally conscious. Being able to accurately gather information in precision farming and being able to precisely irrigate involves more than one type of sensor. In fact, there are dozens of different types of created just for soil and crop sciences, many of which are dedicated just to hydration and irrigation. IoT systems in general generate a large amount of data, and IoT irrigation systems are no exception. Therefore, the most recent innovations and trends in this area are related to managing and analyzing big data. Big data analysis and algorithms are being used to analyze the data produced by IoT irrigation systems. The data is collected by sensors, evaluated, and combined with scientific evidence to provide farmers with the details needed to cultivate specific crops. Artificial intelligence is currently the technology most companies are interested in. In the case of irrigation and IoT, artificial intelligence, or AI, offers technology that can optimize available resources. As an example, one of these techniques is fuzzy logic, an approach that is used to improve irrigation scheduling. Machine learning is utilized in irrigation systems to learn soil environments and predict soil moisture. And neural networks and the structural similarity index are used in optimized system design. These systems predict soil moisture based on specially developed algorithms and produce optimized irrigation techniques for farmers. Some of the other trends in IoT-based irrigation systems include new forms of data acquisition, adaptable low-cost solutions, and designing of sustainable systems. In addition to sensors, technical developments have led to the use of drones to take aerial images of fields and robots that can travel, take measurements, as well as irrigate parts of a farm if needed. As we discussed earlier, many modern solutions are costly, and many countries and many farmers cannot afford commercial IoT irrigation systems. Therefore, most of the solutions that are offered by current researchers, engineers, and scientists are made with low-cost sensors and controllers. Open Garden Shield from a company in Spain, SparkFun Electronics, Arduino boards and connectors, Digital and analog pins in Otterfruit's Industries moisture and hydroponics connectors are all examples of companies that offer low-cost options for farmers to integrate into IoT irrigation approaches. Aside from financial challenges, many rural areas that could benefit from using IoT irrigation systems do not have access to the power grid. Therefore, any built system needs to be usable with the given power resources, utilizing only the power means necessary and introducing alternative solutions like solar power and altogether more sustainable systems. IoT systems in general face security concerns when attackers exploit their unique vulnerabilities. In addition to any risk that an IoT system faces, IoT-based irrigation systems have their own unique challenges. However, specifically identifying the security risks for an IoT-based irrigation system will help us to determine which aspects of IoT security need to be prioritized. A comprehensive study performed by specialists in Valencia, Spain, identifies the security threats that are specific to water management systems and the security measures necessary for a water management system to be considered secure. The identified security threats were broken down into 4 categories. Physical attacks include any physical interaction with a device that can cause harm, such as accidental presence of animals that could damage or disconnect devices, as well as weather conditions that can damage equipment or render it temporarily inoperable. Because farms are generally exposed, physical harm could also come by intention, and attacks could be performed by direct access to nodes or intentional disconnect of power sources. As a solution, exposed nodes should be enclosed in a protective box that is secured with locks or passwords whenever possible. Moreover, if devices are lost or disconnected, their connected systems should alert administrators. The non-physical attacks described in the study, or cyber attacks, are further described in 3 parts. Attacks on the data in transit aim to make the system unable to transmit its data by eavesdropping and tampering. Proposed security measures include data encryption and protection of networks. Attacks on the management system include man-in-the-middle attacks, where data such as system alerts could be intercepted. Tracking exchanged messages and detecting abnormal behavior could help to detect this type of attack. For eavesdropping, encryption techniques could again be utilized. Furthermore, the system must be designed to avoid rogue gateway attacks or remote attacks on secure networks. All devices must be configured with passwords. Attacks on the data itself gathered by the system could be compromised if accessed by a malicious third party. Therefore, encryption techniques, secure passwords, and authentication should be used to avoid threats to data integrity, confidentiality, and availability. In spite of these concerns, new technology and applications are coming to the surface to support this movement, which we have identified in 3 categories. Our first category is open source and low-cost applications, which are important in rural environments in order to promote a wide adoption. This category also includes platforms for non-technical users that must be available to allow farmers to interact with the smart objects needed for an IoT irrigation solution. IFTTT, or If This Then That, offers a free web platform for users to create a chain of conditional statements that they can then use to connect devices. Zapier allows users to create systems to automate repetitive tasks, and Wigwag is a commercial web tool that simplifies smart environments by integrating sensors, smart devices, and the internet. These, among others, have joined in on the effort to offer web applications that provide task automation tools for this purpose. Our second category is management of rules application, a class of tools that enables users to create more complex and sophisticated steps, but do require more advanced technical skill. Node-RED, JBoss rules, and open rules, among others, allow users to synchronize the behavior of smart objects by graphically sketching their interactions. While the previous solutions are designed to help farms implement general web technology, our third category includes solutions specifically designed with IoT in mind. Zeta, built on top of Node.js, is used for creating IoT servers that can run across a huge geo-distribution and the cloud. Thingsboard is an open source IoT platform used for data collection, processing, visualization, and device management. KA is a production-ready, flexible, multi-purpose middleware platform for establishing end-to-end IoT solutions, connected applications, and smart devices. And Thinger provides a scalable cloud base for connecting devices. The ways that the proposed technical solutions have been implemented are understandably varied, as each farm holds its own capabilities and limitations. Where large commercial farms might be able to implement pre-packaged solutions, smaller farms who don't necessarily have access or the ability to implement the same solutions are still using IoT in their farms and implementing precision farming concepts. Before we talk about that, we'll briefly cover some of the pre-packaged solutions. Some of the major companies that offer smart irrigation solutions are listed here. Many large companies are making substantial investments to develop commercial IoT-based irrigation systems because they realize the market potential. However, the sector of IoT-based irrigation systems is currently in an introductory growth phase. Many farmers don't realize the potential benefits related to smart irrigation, and many more cannot afford expensive commercial solutions. Therefore, we've chosen to provide detailed examples of farms who've deployed low-cost and open-source-based systems in limited environments. In Malaysia, a cocoa nursery implemented a smart system for automatic drip irrigation designed to create optimal soil moisture conditions for healthy plant growth. They accomplished their system at a low cost using a Raspberry Pi 3 Model B, a powerful single board computer with wireless LAN and Bluetooth connectivity that retails at just $35. Their developed system collects information on soil moisture, considers the measurements, and then determines the amount of water that is needed for the plants through the drip line. The information is monitored and actions are triggered through ThingSpeak, another open IoT platform. A user with a smartphone can interact with ThingSpeak to monitor their system. Their system suits them perfectly, releasing drips of water automatically when the sensors sense that the soil is too dry and not operating when the release valve when the soil moisture is ideal. Not only is the irrigation automated, but the cocoa plants thrive and the farmer is able to reduce the need for human labor. In Sharandeep Chakaria, a remote area of Bangladesh, a system has been designed to benefit an entire farming community where many different crops are grown. Sharandeep Chakaria has practically no access to the power grid, so a solution was developed using solar power as a main source of energy. The installation cost was kept very low, using an Arduino device and a GSM SIM 900A to control a water pump and send information about the soil moistures through a level server or mobile application. Each of these devices can be purchased for around $30, and the design system communicates with the farmers via their mobile phones. To transmit data, an MQTT protocol system was established, optimal for low bandwidth and the 3G network in the area. As a result, regardless of the farm, less human intervention is needed for agricultural practices. The system is optimized for lower bandwidth, and a sustainable solution was created with the use of alternative energy. Though there is evidence of farms' success in implementing IoT-based irrigation solutions, there are still challenges that remain in the field. Internet spreads on a constant basis. Still, many farms in rural areas are left disconnected, and any IoT solution requires at least some form of internet connectivity along with significant power and bandwidth. Every node in an IoT system transmits to a remote cloud, which can further cause cloud congestion that results in latency issues. Even though advancements in IoT have led to less expensive technology and more widespread availability, and we've seen examples of success in rural, remote areas, accessibility has still been a challenge for some developed countries. In the case of Pakistan, a country well suited for agriculture due to its large amounts of arable land and climatic variations, remote sensing-based technologies are seldom used because of lack of resources. And instead, the continued reliance on traditional farming practices results in the inability to yield a massive amount of food, in spite of their ideal farming conditions. Farmers who have the internet access and the power, technical ability, and are aware of IoT solutions might be resistant to investing in them due to their wariness of potential security and privacy issues. And as our world becomes more technical, Those who are left behind can struggle to keep up with the use of current technologies. Non-technical farmers might be unable to implement IoT solutions unless there is a way to bridge the technology gap. We know there is a need for automation and optimization in irrigation systems, developed with a smart solution that can be obtained with IoT. Precision farming and new technologies are key in the solution to implementing IoT systems for irrigation. However, security concerns remain for any implementation of a web-based application or IoT system. Tech companies are rapidly joining in on the IoT and agricultural industry, and both commercial and rural farms are utilizing IoT approaches to improve their irrigation systems, but there are many challenges that must be overcome before IoT can be widely used. The agricultural sector has not traditionally been the first one to adopt innovative technologies, but we hope this will not remain a trend, as there are many economic and environmental benefits to modernizing an irrigation system used for the Internet of Things.